In this question, we have to determine C1 C2 by R1 R2 whole squared, where C1 and C2 are two of the outputs or the two outputs of the system, and R1 R2 are the inputs of the system. Now, C1 C2 by R1 R2 whole squared can be written as C1 C2 by R1 R2 whole squared can be written as C1 by R1 into C1 by R2 into C2 by R1 into C2 by R2. Okay, so I have to determine C1 by R1, C1 by R2, C2 by R1 and C2 by R2 in order to determine whatever is asked. Now, to determine C1 by R1, I have to consider this system. The output of the system I have to consider as C1, and then I have to consider R1 as the input, which means actually I can consider the system to be having both the outputs, but it is very necessary for me to take the other input as 0. Okay, for example, if I am determining C1 by R1, I have to assume R2 equal to 0. That is the conventional method. Okay, now in order to determine the transfer function C1 by R1, since I am going to consider C1 as the output and R1 as the input, now I have to first determine the number of forward paths. In that case, I have to see the number of forward paths leading from R1 to C1. Okay, so that way if we see there is only one forward path, okay, along this straight line, okay, having a gain of 1. Okay, so C1 by R1 is equal to 1 into, I have to determine del 1. Del 1 is the determinant of the loop that is not touching the first forward path, or in this case the only forward path. If we see here, there is a loop here, okay, that is not touching the first forward path, having a gain of -1. Okay, so I will get 1 minus -1, so it is 1 plus 1 divided by, okay, now I have to determine del. Okay, to determine del, I have to take all the loops into consideration. Now if we look at the system, we are having 3 loops. There is a loop here having a loop gain of -1. Similarly, there is a loop here, and if you observe closely, there is a loop here. It starts here, then goes like this, and then since it is not touching this, but there is no intersection here, so there is no problem. Goes like this, comes like this, and then again like this. Okay, so there is another loop over here. If you see clearly, if you observe very carefully, you can see that the loop gain of this particular loop is equal to 1. So I am having 3 loops here. So I will write this as 1 minus sum of individual loop gains. Two loops are having gain -1 and -1, and the other one is having +1, and then this loop and this loop are not touching, as a result of which I get an extra term, it is +1. So this is equal to 2 by 3. Now to determine C1 by R2, I have to take C1 as the output. Okay, I have to take C1 as the output with R2 as the input. In that case, I have to look at the forward path, which means the path leading from R2 to C1. Okay, if I see there is only one path. Okay, it starts here, comes like this, goes like this, like this, like this, and then terminates at C1. Okay, so this is the only path we have, only one forward path with a path gain of 1. So this is equal to 1 by again determinant for all the transfer function is the same, because it is not dependent on the input or output, it is merely the determinant of the system. So I will get -1 -1 +1 +1. Again here I am having del 1 as 1, because there is no loop that is not touching the first forward path. Okay, this I am getting as 1 by 3. Similarly, I will get C1 by R2 is equal to 1 by 3, and C2 by R2 is equal to 2 by 3. Now I have to substitute these values to determine C1 C2 by R1 R2 whole squared. So that is equal to 16 by 81. It's equal to 0.197.